Heirloom utilizes a type of compiler called a transpiler to quickly and accurately process tens of millions of lines of COBOL and PL1 to create Java source code that is guaranteed to be functionally equivalent. It is able to do this because the Java code utilizes Heirloom's Java framework. This framework extends the capability of any Java application server to execute mainframe workloads with absolute precision. This live demonstration of Heirloom's generative AI solution, called GENAI, showcases how the dependency on Heirloom's Java framework can be replaced by standard Java libraries. GENAI has been built on an augmented LLM with metadata from hundreds of millions of lines of real-world mainframe application code and testware that Heirloom has already accurately transpiled to Java. Okay, let's start. We're going to take a COBOL program, transpile it to Java with Heirloom, and then use GENAI to refactor it to standard Java code with no dependencies on the Heirloom Java framework. This COBOL program uses a VSAM file to create tests of division calculations that use complex numeric edited COBOL data types. We're now going to execute GENAI. The first thing it is going to do is to use Heirloom to transpile the COBOL program to Java source, which is then compiled by the Java compiler to create classes for execution. We then execute the program and save the results in a res file which will be used to compare the results of the refactored code modified by the AI. This is the Java code produced by Heirloom's transpiler. And this is the result from executing the COBOL program. As you may already know, COBOL has very unique rules about the precision of calculations and how those results are displayed. The next step is to instruct the AI to refactor the Java code to remove any dependencies on the Heirloom Java framework. The AI returns its first attempt at refactoring the code. GENAI then compiles the response. The good news is it compiled clean on the first attempt. However, execution resulted in an exception being thrown. This is the code returned by the AI. Looks pretty good. But what happened to the execution? Let's take a look at the res file to see. Yep, there's the exception. No problem. We're simply going to pass that result back to the AI and ask it to try again. This time, the second iteration compiles clean and executes without any exceptions. However, the results produced do not match the original COBOL program. Here are the full results from executing the second iteration. Not bad, although there are some minor but obviously important differences in some of the calculations, and the formatting is not good. Will third time be a charm? Let's see. This next part of the video has been sped up to keep things concise. What happens over the next few iterations is that both the calculation precision and the formatting improve with each new attempt. With each iteration, the AI gets closer and closer to the required outcome. This iterative approach is necessary because generative AI is by design fundamentally non-deterministic, as it uses probabilistic methods to generate output. On the seventh iteration, which is eerily biblical, GENAI has successfully orchestrated the automatic production of a functionally equivalent Java program that no longer has any dependencies on the Heirloom Java framework. We can perform a simple verification of the result by simply executing the original Java program created by Heirloom's COBOL transpiler, followed by executing the refactored Java program produced by GENAI. The results are an exact match. Finally, let's take a quick look at the refactored Java program. The first thing to note is that only standard Java libraries are required for execution. As you can see, the rest of the code is well-structured, easy to maintain, and faithfully replicates the functionality of the original COBOL program.